Hello, everyone, and welcome to the first Tracerco podcast, a new series looking at Tracerco's diagnostic techniques and how they benefit users in the energy industries. This podcast is aimed at anyone that works in the chemical process industries, as well as anyone that wants to learn more about refining and petrochemical production. My name is Rob Hardy, and I'm the commercial manager for Tracerco in Europe. I'm joined today by my co-host Bill Rivers in Houston, Texas. Hey, Bill, how are you doing?
I am doing great, Rob. How are you doing?
I'm doing okay. How are things there?
Wet and rainy. It is not a Disney type of day.
No, well, yeah, the sun is normally shining, wildlife everywhere.
I know, rainbows out, songs in the air. Good night. Not today. It is wet and dreary right now.
Oh man, I'm sorry. I'm sorry. All right, so what we're going to do in future episodes is we're going to look at our range of process diagnostic techniques. We're going to look at some case studies and real world examples. We're going to bring in some technical experts from across the business, as well as some interesting guests from the broader industry. But for today, what we're going to talk about, Bill?
We are going to talk about pack bed analytics.
Oh, interesting. This sounds complicated.
Not really. It's we use a technique called a Tru-Grid scan. So
Mhm.
that's one of our techniques we like to use to scan packed beds. But before we go down this line,
Mhm.
what is the number one reason we get called out to scan a packed bed tower?
Yeah, so I guess over in Europe, we're looking for things like the condition of internals. We're looking at flooding and foaming, but probably the number one thing is maldistribution.
You got it. That is the number one reason over here in the United States we get called out to scan packed bed towers, just to
Mhm.
look for maldistribution. But I think before we get down this road, Rob, I think we kind of let's take a step back and we'll kind of talk to our audience about what a true grid scan really is.
Uh-huh.
So essentially, when our guys and girls come to site, right, they're gonna be packing a radiation source and a detector. They're gonna climb to the top of your tower and they're gonna hang the radiation source and the detector off a reel system,
Hmm.
right? Once everything's set up, it'll roughly be about 180 degrees apart. And when they hit go, both the radiation source and detector are going to drop in unison together, roughly about 3 inches. And it's going to take and hold for about 3 seconds. And it's going to take a data point. And then it's going to drop another 3 inches, hold, take another data point. And from that, we're going to go all the way down the tower like this. Once we get to the bottom, we're going to reel everything back up to the top, rotate 90 degrees, and repeat the process, you know, 3 more times.
Yeah, and I mean, it sounds like a really simple technique, but it's actually quite elegant, and you can get a lot of very detailed information. And the analogy I always think about is it's very similar to an X-ray. So you mentioned about a detector and a source, very similar to an X-ray that's looking at transmission across the human body. And with a one-shot X-ray, you would get information about the bone structure and any fractures that you have. And in the same way with the tower, if we did one scan line, we would get quite a simplistic piece of data. But you mentioned about doing rotating, having another scan line, building up this picture across the tower. So that's more similar to a CT scan that uses multiple scans to build up tomograms, density maps, much more complicated information. So from this very simple technique, we can start to build up highly detailed information. We can start to look at the conditions of the internals within the tower. We can diagnose flooding, foaming, maldistribution, and that sort of thing. So quite a simple technique, but a lot of really good data that we can get. So what do the results look like, and maybe we could speak a bit about the interpretation and that sort of thing.
Yeah. So, we go back to mention about the points, like the data points that we take, right? Essentially what we're doing is we're playing connect the dot. Like, you remember connect the dot with your kid, when you go on long trips and your parents want you to shut up and they're trying to keep you busy for the next 4 hours, they throw one of those books in the back and the title says learn to count to 500. You get your crayon out and you sit there and you start playing connect the dot, and it creates these great pictures, and by the time you get to your destination, yeah, you can count to 500, right?
Mm-hmm.
Sort of like the same concept. We're playing connect the dot down the tower, but we're creating a density profile. And remember, we have 4 different scans on a larger tower. And the way we kind of interpret that data is if all 4 scans overlay on top of each other, it means you have great distribution of product going through your tower. If one of those scans tends to like pop out from the rest, then you might have a slight issue going on in that section of the tower.
Mm-hmm.
So it's kind of the way, going back to, what you were talking about, how it's a very simple and easy scan. It is just the overlay of the scan. You can kind of basically tell right there on the spot what's going on inside your tower.
Hmm. Yeah, I guess another thing that we haven't mentioned yet is that it's in a way, in a similar way to the X-ray. This is non-invasive. We don't have to stop the process, do we?
Absolutely.
You
Yep.
know, we can turn up on the morning, we can scan the tower. You don't interrupt the process. So that's another advantage. Also, it can be used to monitor towers over time and look at ways things are changing over time. You can compare the data for single towers over multiple scans over multiple periods of time. So it's quite a versatile technique as well, isn't it?
Yeah, and to your point about talking about monitoring towers over time, we created a process called PackView.
Mm.
And before I dive into what PackView is, got to tell a little bit on Tracerco here, right? In the good old days, data was considered subjective. Depending which technician showed up on site, excuse me, you had a different interpretation of the data. So that's why we recognized that problem here at Tracerco, and so we created PackView.
Mm.
So if I were to cut my hand right in front of you, just to illustrate my point about subjective data, my favorite example when I first got hired on at Tracerco was taking a knife and slicing your hand right in front of somebody. It's very mental. I don't highly recommend that anybody to do that whatsoever. But if I were to do that in front of you and held up my hand, Rob, and I said mild, moderate, severe,
Hmm.
and you look at me and go, I think you didn't cut it deep enough. That's a little bitty cut. Go back to work, quit whining about it,
Hmm.
right? Hold up to somebody else. Oh, that's a moderate cut. That's some stitches right there. You better go see the nurse right away. And for me, I'm thinking hand surgeon. I'm out 7 to 8 months, getting it done. It was a very subjective way to view the data. But with PackView, we actually created a scale, a density scale that we overlay on top of the scans. And the way it works is we start off with your dry packing density, which you can give that to us, or our guys can look it up for you, right? And then from there, it goes in increments of 5, foot-pounds per cubic foot is what it does. So once we overlay that, density scale along with the scan lines coming down on there, you can get a really clear picture of how your tower is performing over time, because it has really quantitative data at that point
Hmm.
that you can look at and measure and monitor over time.
Yeah, and then I guess the next step is to take it to the quantitative data, isn't it? And that's really useful in diagnosing exactly what's going on within the tower. When you identify areas of differing densities using the PackView system, we can figure out whether or not it's damaged packing that had fallen. We can actually even look at the process fluid density, can't we, and see if it's
Yep,
yeah.
absolutely.
Yeah, okay, great. So I mean, one thing, examples we've seen even on smaller towers where we perhaps only have two scan lines, is you can quickly identify those areas of increased density and diagnose the problems and whether or not it's the process fluid flooding and that sort of thing. But when we go to bigger towers, we have the 3 or 4 scan lines and the grid view scan that we talked about. Is there any differences in when we have areas of different types of packing in these bigger towers, or is it the same sort of process?
It's the same process, same technique, but it's always good when our guys show up on site to let us know, or let us know that there's different types of packing inside that tower,
Mm.
right? You can have structure packing, you can have dump packing, but it's always good to let us know either before we show up on site or once we're on site, so our guys can do the correct interpretation of the data. To your point earlier, Rob, you had mentioned about how an X-ray comes about, and how a technician could come in and interpret the X-ray about what's going on inside your body. That's what our guys are. Our guys are the technical experts and technicians on site that can read all those different types of profiles going on,
Mhm.
interpret the data for you right there on the spot, and to make sure that you're getting the customer's getting the most accurate information right then and there.
Mhm.
You and I've been in the oil and gas industry forever and a day, and you both know time is money, right? If customers have off-spec product, they can't sell it, and it costs them not tens of thousands, but it can cost them sometimes hundreds of thousands, even $1 million a day,
Mhm.
right? Depending on what type of product they're making.
Mhm.
So it's just a great technique that takes hours to do, just so our customers can get good data, make great decisions, and get their process back up and running fairly
Mhm.
quickly.
Yeah, yeah. No, that's great. I think some of the most telling examples really are where a customer has an off-spec product, and that's the last thing they want, isn't it? So
Yep.
what we can
Absolutely.
do, and what we've done numerous times, is there's an off-spec product. We come in and look at the tower. That problem, when you look at it from the outside, is quite complicated, and you could think about it for hours and theorize about what could potentially be going wrong and causing the off-spec problem. But we can scan the tower really quickly, and quite often we diagnose the maldistribution extremely quickly just from this quick scan.
Yep.
And you can get the customer back up and running, get the product back on spec really quickly. So yeah, it just shows how effective this technique is, doesn't it?
Yeah, time and money gives them great data so they can make great informed decisions to figure out what's going on. And our guys on site, right? They're professionals. They're going to come to the site. They're going to give a great analysis right then and there. They're going to tell them what's going on, so you can trust what's going on, with our guys and what's happening inside your tower right there.
Yeah.
Simple.
All right, great. Well, I think that's all we've got time for today. So we've got a case study on the website. It's called PackBed Performance Analytics. So please go on, download the case study. Let us know if you have any questions. Contact us via the website, or you can go onto LinkedIn, search for me, Rob Hardy, or Bill Rivers on LinkedIn. And that's all we've got time for. So we'll see you next time.
Appreciate y'all listening. Having a great day.